This is an RNZ podcast.
Ngā mihi nui and a big welcome to Elemental from RNZ, in which we are gallivanting around the periodic table from A to Z, which, by the way, for any American listeners out there is how we New Zealanders pronounce the letter Z. I'm Alison Ballins.
And I'm Allan Blackman from the Auckland University of Technology, and this is episode 55, which is following on from nitrogen, and that means that we are up to osmium today. And I can claim 1 degree of separation to osmium because my old PhD supervisor worked with osmium compounds during his own PhD back at the Australian National University in the early 60s. His name's Dave Buckingham. If you're listening in Wanaka, Dave, hi. And he really is an underknown name in New Zealand science. So today, osmium comes from the Greek word osme, meaning a smell.
And does it really smell?
Well, I'll tell you in a minute. but firstly...
The suspense is killing me.
I know. We will get to the smell thing. But we have to do the vital statistics first. Osmium is a transition metal, okay, elemental symbol OS and atomic number 76. That's putting it down in the third row of the transition elements in the periodic table. It was first discovered in 1803 along with iridium when a guy by the name of Smithson Tennant found a residue when he took an impure sample of platinum and tried to dissolve it all in aqua regia. Most of it dissolved, some of it didn't, and that's how osmium came to be, essentially. And he came up with the name because of the pungent and peculiar smell of its oxide, unquote. The compound he was talking about there is a thing called osmium tetroxide, and that's quite volatile. It's got a sort of an ashy and smoky smell. So you can form osmium tetroxide from the metal, little bits are being formed, and so therefore, yes, osmium does smell, yes, it deserves its name.
Is being pongy its only claim to fame?
Oh, no. There's many more things about osmium that we could talk about. First interesting thing is that it is very rare. And in fact, it is the least abundant non-radioactive element in the Earth's crust, which is kind of cool. To give you some idea of its rarity, so there's only a few hundred kilos, sort of between 100 to 500, depending on which book you read, that are produced annually.
I like the fact that it's the least abundant non-radioactive element. That's like being famous for all the things you're not.
Yeah, fair point. So that's one of its claims to fame, but its biggest claim to fame is the fact that it is the most dense of all the elements at atmospheric pressure and room temperature. And so if you took a sphere of osmium that was the same size as a tennis ball, that would weigh around about 3.5 kilograms, which really is very dense when you think about it. If you want to compare it to lead, I think most of us think that lead is pretty dense. The same volume of lead would weigh around about half of what osmium does, so very, very dense.
Tennis ball size, you sure as hell wouldn't want to actually play tennis with it, would you?
No.
But anyway, that does make it, by my reckoning, the heavyweight champion of the elements.
Ding, ding. Sure does. But wait, there's even more claims to fame. The metal also rivals diamond as being the least compressible of all known substances, which is kind of cool. And because it is very rare, it is quite expensive. So if you did take that tennis ball-sized lump of osmium, it would cost you around 75,000 New Zealand dollars at current prices.
Whoa, so that smell, that's the smell of money.
Indeed.
Then. But since it's so rare, so pricey, so dense, so incompressible, what do we actually do with it?
Well, to add to that list of woes, the metal itself is also very brittle, and it also melts at a very high temperature, just over 3,000 degrees Celsius, and that makes it pretty darn difficult to do anything with. But that's not to say it's without its uses. A guy by the name of Carl Auer in the late 19th century thought that the high melting point would be good to use in an electric light bulb. So he tried making osmium filaments for his electric light bulb. That was in 1897. Sadly, it didn't quite work for him. It sort of did, sort of didn't, but it got superseded by tantalum first, and then Edison came along with tungsten, and he was the one that made all the money. So on the basis of all of these features, if you want, of osmium, it's fair to say that the metal really isn't in much demand. So what then is it used in? Well, we're going to the high end here, folks. So the very few uses of the element. First up, high-price fountain pen nibs.
Oh, we've done that before.
We did, yes.
Iridium.
We talked about that with iridium, absolutely right.
Yes.
And also clock bearings. In this age of digital clocks, they're probably going out as well. They're used in that because osmium being very wear resistant. So that's the metal itself. In terms of compounds, we've already mentioned the most important compound of osmium. That's osmium tetroxide. And that was the smelly stuff that we were talking about. Very important, this is a colourless solid that you can form simply by heating the metal in the air. It's got a few uses. It can be used in certain organic chemistry reactions for the chemists amongst you. And if you really want to know, these reactions are called cis dihydroxylations, which you'd probably know about had you studied first-year chemistry.
Oh, yeah, get on with it.
Also used in fingerprint detection, quite an expensive way of detecting fingerprints, but quite good apparently. And it's also used as a stain in microscopy. Again, expensive. OSO4, osmium tetroxide, it is very volatile, and so you've got to take extreme care with it because it is highly toxic. And if you inhale it, you will probably regret it. It certainly can kill you. And also the vapour is not good for the eyes, and that will also cause blindness if you come into too much contact with the vapour.
So in my books, that means osmium is eye-watering in several ways then, price and toxicity.
Indeed.
Now, when we did iridium way back in episode 39, I think it was, we bemoaned the lamentable decline in the use of fountain pens and nibs these days. So I'm figuring that unless I commit a crime and have my fingerprints dusted, I'm really very unlikely to come across any of it in my everyday life.
Yeah, that's probably very true, but it's interesting that you mentioned crimes there because given, as you say, its eye-watering price that we talked about, it was very, very surprising that this compound was apparently going to be used in, of all things, a terrorist attack in the UK in 2004. You read the papers back then, and apparently a bomb containing osmium tetroxide was going to explode. It was going to spread the osmium tetroxide over a wide area. People were going to inhale it. They were either going to die or be blinded or both. And police ended up arresting 9 people in connection with this. And despite my hard work on the internet, very, very difficult to actually find out what happened to these people. A really weird case, this.
What a dense idea. Sorry. I'm glad they were foiled, I have to say. And I'm very pleased to have heard of the heavyweight champion of the chemical elements, but I think I can happily spend the rest of my life without actually coming across osmium or its oxides. Unlike the Elemental podcast, which will continue to be a regular feature of our lives until the end of the year.
And if you'd like to relive any of the earlier episodes of Elemental, osmium's twin iridium, for example, you can find them all at rnz.co.nz/chemistry.
Or just scroll back through the Elemental feed on your favourite podcast app. We're back next time with Oxygen, but until then, it's farewell from me, Alison Ballance.
And goodbye from me, Allan Blackman.